Okay, so in 7.3, Chapter 7, Pre-Cal 30, we're talking about compound interest. There's a question or two you might run into. So notice that I don't know how much you guys know about money or investing or interest payments. If you take out a loan for a car or something, there's compound interest. That means that interest is calculated on the total, not just the original amount, but the total amount that is currently owing. So if you, let's say you take money out for a car, you take $5,000 out for a car, and you're going to pay this over 5 years or something. Well, you're not going to be paying back just the $5,000. There's going to be interest, okay? And if it's a certain percentage of interest after the first, little while, let's say you're 6 months in, and now that $5,000 is actually turned into $5,100, okay? So now the percentage of interest is now charged on the new amount, not on the original $5,000 anymore, but on the new amount. That's called compound interest. It compounds. If you invest, compound interest works for you really nicely. So if you invest $1,000 after, let's say a number of years, that $1,000 grows, and you actually get a certain percentage on always the updated maximum amount. So whatever your account is, you get the percentage of that, not the percentage of just the original. If the percentage always goes back to the original amount, that's called simple interest. If the interest is always calculated on the current accumulated amount, that's called compound interest. Now, simple interest, let's just think about this. $1,000, if you had, I should make that a 10 or something. So if you had 10% of $1,000, right? So you would do 1,000 times, that's the same as 1,000 times 0.1, right? So 10% would be 0.1, you'd back this decimal off 1 over and you get $100. Does that make sense? That's 10% of 1,000. Just knock that decimal place back 1 and that's your new amount. And so if you got 10% interest over a certain amount of time, you would add $100, and so your total would be, I'll do it down here, your total would be 1,100, right? That would be your new total, okay, with the calculated interest. All right. If it was 1%, okay, or let's just say you had now compounding interest, and you had another 10%. Okay, I've changed this a bit, but now you've got 10% of 1,100. You see, 1,000 went to 1,100. So now if you've got 10% of that, that's going to be $110, right? This was $100. Now the interest is $110. So now your new amount becomes 1,100 plus 110 is 1,210, right? So you see how it builds. Each amount of interest, when it's calculated compoundly, it grows. It gets bigger each time. Simple interest, it would stay the same each time. All right, which leads us to this formula that you're going to be seeing, and I'll just pause at the screen here for a little bit, and I'll try and explain each one. So this says A equals P times, in brackets, 1 plus I, bracket, to the power of n. So this n is just to these brackets here, okay? Just applies to those. But the A is the future value, or future amount. So if you're investing a certain amount of money, you can calculate what the future amount will be over time. And so this is the future amount. P is the principal amount, or the original amount, okay? So let's say I'm putting in $1,000, I can calculate what my future value will be. This is the principal, okay? $1,000 would go here. So I is the next variable, and that is the interest rate per compounding period. Now I have to talk about compounding periods because that's what this exponent of n is. So if your investment compounds annually, that means that the interest is calculated every year. If it's compounded quarterly, that means it's compounded 4 times a year, each quarter of a year. That's every 3 months. If it's compounded monthly, that means it's calculated 12 times a year. All right? So let's say that you have, now look at this question down here. You have 4 years compounded quarterly. Well, that's 4 years times 4 calculations per year. That means that n, the total number of compounding periods, is 16. It's 4 times 4. All right, if you had 4 years and the interest was compounded monthly, then that would be 4 times 12, or 48 compounding periods, right? And sometimes, like when you owe money on a credit card, how many of you have credit cards in here? You guys aren't old enough, right? Not mostly. So when you get a credit card, because you probably want one eventually, because they are pretty easy. They're good. They're nice and easy to use. You got to be very careful with paying off your credit cards, though, because the interest calculated on credit cards is compounded daily. So if you owe money, like if you don't pay off in time and interest kicks in, then they will take your interest every day. They will calculate interest, and that will compound every day, which means that you will be paying back more than if it was compounded less frequently. Now, the percentage per day and the percentage per month and so on is not the same as the annual percentage. As a matter of fact, if your annual interest rate, and credit cards are sky high, like mortgages for a house is like 3-4%, something like that, let's say. But interest on credit card debt is like 22%. It's high, it's super high. And so, and they don't wait for a whole year to go by before they calculate that interest. They do it every single day. So it's not 22% a day, but what it is it's 22% divided by 365. So it's a very small percent, but they take that and they calculate the percent every day, so that your account, what you owe, goes up by pennies every day. And before you know it, it grows really quickly, as opposed to if they calculate it just once a year. Does that make sense? So the more often that you calculate compounded interest, the more money that will be accrued or will be gathered. Okay? All right, so now that you know this, this is how you can calculate your future value. So let's just do a little test here. I'm going to make a little space. Okay? Let's see if I can separate this properly. Oh, that's pretty good. Okay. So let's use this formula, and let's use our first example that was 10% of 1,000. So let's say that we have $1,000 is our P value. Okay. You're going to multiply this by 1 plus the interest rate. So the interest was 10%. Let's say it's 10% per year. Okay. Let's just say. So this little I is going to be the interest rate per compounding period. It's going to be in decimal form. So you might want to just write that decimal form. So this is going to be 1 plus 0.10. Okay. Per compounding period, and the compounding period is years. So let's say, and this doesn't happen very often where it's only compounded yearly, but let's say we're going to see what it's like after, well, let's say after 1 year. Okay, after 1 year, because we kind of calculated that, didn't we? We calculated it right here. So let's see if this formula works so far. So the future amount, the future value is going to be 1,000 times 1.10 to the power of 1. So BEDMAS says that you have to do this exponent first. Well, I did the brackets first, and then the exponent next, and then the multiplication. So on your calculator, it should look like this. 1,000 times 1.1, and that's going to be to the power of 1. So that's 1,100. So that's what we calculated before, right? So if this is going to happen for, let's say that you guys, oh man, I don't know if you have any money, if you have jobs, but if you were smart, if you were forward looking, and I know you're all smart, but if you could do this, you would try and put some money aside right now for your future self. Because when you're old and gray like me, if I had put $1,000 in when I was 18, and it compounded 10% even just yearly, that $1,000 would grow quite a bit. So let's just find that out. So what are you guys? How old are you guys on average here? 16, 17? 16, 17? Okay, so let's say 16, and I'm 51. So what's that? What's the difference there? 35? 35? Okay, so let's say we want to know what our future amount is. I won't use red. I want to know what future amount is. If you put in $1,000 when you're my age, what would that turn into? So that would be 1.1 or 1.10. So that's going to compound yearly for, what did we say? 35 years? 35 years. All right, let's give this a test. So go ahead and put this into your calculator. Make sure that you're calculator works. Okay? Go ahead and put that in your own calculator and see how much money you would have when you're old and gray like me. Okay? Calculator, go. Do it on your calculator. Make sure your calculator, use your brackets, where's your exponent button, all that sort of stuff. To the power of 35. So you would have, okay, my goodness. Okay, if you guys were able to scrounge up $1,000 from your job, might take you a year. I don't know how much. It probably wouldn't. You don't owe rent. You don't have to pay much, right? You guys have a lot of disposable income. If you were to save $1,000, take you a few months maybe. You put that in the bank, and I don't know what kind of interest rates you could get. But what this says right here, look at this. If you put $1,000 in the bank and forget about it until you're like an old gray person like me, and I'm not that old. I still got a lot of life left. But to have 28 grand in the bank account at this stage of life would actually be really, really handy. And it's nothing that you've done other than put up the original amount of money and let it just sit. Now let's say that you wanted to do that and I wasn't needing it now. Let's say I was going to wait till retirement, maybe you're 65. So 16 to 65 is going to be what? 49 years? So let's do that again and check what it would be if you did 49 years. So we'll go back, type in 49. You have $106 flipping $1,000. Kidding me? Wow. Can you imagine? And what have you done? Nothing. Just let it sit in the bank, right? Or sit in wherever. You invest it. Anyways, I never thought about this when I was your age. Honestly, it never even crossed my mind. And did I have $1,000 when I was 16? No. I was working, and I bought a car instead. Okay. So if you're gonna buy a car, I get it. Need a car. But shoot, if you can put in $50 a week from your job, and then when you get $1,000, boom, put it in the bank and forget about it. Just try and forget about it. When you go to retire, 65, you'll have at least $106,000 in the bank. What could you do with that? Wow. Now, you'd have to look up and see what kind of percent you'd actually get.
It's usually like 3%.
Well, it's usually, it might be less than this, but it'll be compounded more. So that's just an example. So it would be worthwhile to look that up and see what kind of investments you could get for long-term stuff. But that's kind of how that works. Everybody understand that? Future value, principal value. Now, if the compounding period was not per year, all right, if this was per month, let's go back and change this. Okay, let's just do this little thing. Let's say this was per month. Now that is a lot per month, 10% per month. Then what you'd have to do, guys, watch this, okay? You would have to change some things. You would have to say this decimal would be actually 10% or 0.1 divided by 12. Okay, so it would be a 1/12 of a 10%. But that would happen, that would get calculated 12 times per year. Okay, so let's do that. Let's figure that out. So 0.1 divided by 12, it's going to be a super small number. I get it. 0.0083333, okay? So 1.008333 repeating. Okay, 00, right? Was it 00? Yeah. All right. So now, after 1 year, remember we had 1,100 before. So if we compound the same percentage, but we do it more often, then this is what we're going to get. Let's see if I can get my old entries back here. Okay. I'll keep going one more time. Okay, so now I'm going to make this, oh geez, can I insert this? 008333333. Okay, it's repeating, so I'll put a lots in there so it's more accurate. Now what? Wait a minute. 1,000 times 1. Oh, to the power of. I didn't change to the power of. My mistake. Hang on. Power of 12. That should be a 2 there. Okay, there we go. Look at that. So you get almost five more bucks in the year. And that's just from changing the frequency. Doesn't seem like much, but if you invest $10,000, right? That's $50 a year. That's a little bit better. And that's just from changing the amount of times it's compounded, okay? So 1104.7. Something. So that's the power of compound interest. So the other thing you could do, guys, you could solve for, right now, without using logarithms, it's going to be tough for you to solve for compounding periods, but you could solve for annual percent. You could solve for this little value here, right? You could solve for the principal amount given the future value, right? Like if I said, okay, this, how long would it take, or what would it take for you to put in the bank right now to make this in 12 months compounded annually? Here you go. And you solve for X. And you work it backwards, and you'd say, oh, it would be $1,000 I'd have to put in to get this much. Okay? All right. Now, actually, let's do one more. Let's just do one more. Remember so let's say we did this, but it was for 49 years, okay? So this is 49 times 12, right?
88.
Sorry?
588.
Whoa, hang on. $1,000 compounded monthly for 49 years. Remember the old number was 106,000, I think it was?
Yeah.
Wasn't it? It should be up on the calculator still. Oh, maybe not. And so what is this one? What is it?
588.
588.
Sorry, to the power of 588 is what 49 times 12 is.
Oh, I'm see what you're saying. So this number is 588. Okay, you can actually just put in 49 times 12 if you want. Like for example, you can go 1,000. Okay, then bracket 1.083333, and you could put to the power of, and you could just do all this at once.
There's 2
Times
zeros.
12. Did I just put 10?
Yeah.
I think I tried it too. Anyways, okay. So let's see. Now this is going to be 131,588. 131,588. So the old mark was about 106,700 or something like that. Check this out. Just changing the compounding periods, the amount that it compounds, like the same percentage, but just the number of times compounding. Look at that. Wow, $25,000 more over till your retirement. That's crazy. That's crazy. Okay, so compound interest. Any other questions? Okay, in your number 11, I want you to do number 11 right now for sure. Okay, yeah, let's just do number 11. Add that to your assignment, number 11. I'll keep it up on the board for a second here. Number 13 is another one. I'll make that optional, but number 13 is a similar question to it. And then if you're done the assignment in the amount of time I'm giving you this class to do it, I would like you to look a little deeper into the extend questions, okay? Do some more of these if you're done the assignment. So the new assignment here, oh, let's get back to, so where is it? Okay, so this is going to be, 11 is going to be on there too, and then optional extend questions. All right, I would strongly encourage you to get a little extra practice there. Got it?
What?